What's good everyone, you're back with your boy Jono for another quick math lesson. Today we're going to have a look at how small changes to a linear equation can completely change the graph that you end up looking at. Just before we get into today's lesson, we do just have to make sure we're on top of a couple of really key terminology points. In the last few lessons, we've been a bit relaxed with this terminology, just trying to illustrate the point that each term is trying to represent. But in this lesson, we've got to really dive into the specifics of what these terms are and what they mean. The first term that we've got is the gradient. And the gradient is really a fancy term for the pattern that we've been talking about. So what this means is that every time x changes by 1 or goes up by 1, there is a change in y. And we've been calling that the pattern. So if it's 3x, that means that as x goes up by 1, y goes up by 3. Some people call this the slope, and really what the gradient does is tells us how fast this line is changing. The other thing that we need to know is called the Y-Intercept. In the last lessons, we've been calling this the beginning number, which isn't really correct because a linear relationship is just a straight line that goes on forever and ever and ever and ever, so it doesn't really have a beginning or an end. So we've been using that as when x is equal to 0, what does y equal to? So that's what the y-intercept is. What it really means on a graph is where does our line cross the vertical axis, so the axis that goes up and down, where does our line cut straight through that, or where does it intercept it? So what we're trying to do in this lesson is we need to know how do these things, the gradient and the y-intercept, change our lines when we graph them. How does it change the pattern that we've been given? So we're going to look at what happens to the y-intercepts first. In these three equations, we've got y is equal to 3x, y is equal to 3x plus 2, and y is equal to 3x minus 2. So the gradient in each of these is exactly the same. The gradient for all of them is just equal to 3. What this means is that as x goes up by 1, y goes up by 3. But the y-intercepts for these three are all different. For that first one, y is equal to 3x, the y-intercept is at 0. We don't have to write plus 0 because plus nothing is just nothing, so we just write 3x and the plus 0 is assumed. For that second one, the y-intercept is at 2, and for the last one, the y-intercept is at minus 2. So while it's really good to be able to identify what these terms actually mean, it's going to be really helpful to see it in a graph to see what the difference is when these numbers change. So for this first line here, this is y is equal to 3x. So we can see that the pattern is when x goes up by 1, y goes up by 3. So the easiest way to see this on this graph is that if I go up by 2, so if x goes up 1 and then a second one all the way over to here, the y value is going to go up not by 3, but by 6 all the way up to here, which is exactly true. So every time x increases by 1, y goes up by 3. We can also see in this graph, super importantly, that it passes through the origin, or it goes through the y-axis when x is equal to 0. So if I add in this next line, this is y is equal to 3x plus 2, we can see that the line is going up in the exact same pattern as the previous. We say that these two lines are parallel, kind of like a train track. They're never going to cross over each other. So we know that the gradient is the same. The pattern is still as x goes up by 1, y goes up by 3. The only difference here is the plus 2 at the end of that equation. What that means is that our line crosses through the vertical axis or the y-axis at y is equal to 2. So when x is 0 for this line, y is equal to 2, and we can see that it's elevated 2 positions. Finally, this last line is y is equal to 3x minus 2. Again, the pattern is exactly the same. This one's parallel to the other ones as well. But instead of being elevated 2, because it's negative 2, it crosses the y-intercept 2 positions down, and that's why you can see it so clearly on this graph. So I think the easiest way to think about this is that the y-intercept value, or the number at the end that is a constant, changes the height of the graph. If it's a positive number, it moves the whole graph up that many squares, and if it's a negative number, it moves the line down, no matter what happens to the gradient. So what happens if the pattern changes? In this one, we've got three graphs. Y is equal to x, y is equal to 2x, and y is equal to 3x. So the gradient for each one is getting larger by 1. So the gradient for the first one is just 1. Y is equal to x. Whatever x is, y is that same number. So the first gradient is 1. The second gradient is 2, meaning that as x increases by 1, y goes up by 2. And the third one is 3. For this one, all the y-intercepts are the same and they are all going through the origin, or the y-intercept is 0. So when we look at these three on the graph, we can see something straight away really jumps out. So this first line here is y is equal to x. And what that means is that whatever the x value is, that's the same as the y value. We can see here that when x is equal to 2, y is equal to 2 as well. So that's all that this one's saying. So for this one, the pattern is that y is increasing by 1 every time. When I add in y is equal to 2x here, we can see that the line looks a little bit steeper. This is because the y value is increasing by 2 every time the x value is going up by 1. So it's increasing twice as fast as before. And what that looks like on the graph is this steepness of the slope is increasing. Finally, that blue line is y is equal to 3x, and again, this line becomes even steeper still. So the gradient here, 3x, is saying that as x increases by 1, y increases by 3. So that means the line gets higher faster. All three of these lines still go through the y-intercept of 0, or the origin, because there's no constant term at the end of them. So the easiest way to think about this is that the gradient changes the slope of the line, or the steepness of the line. It's actually sometimes called slope for this exact reason. So the higher the value, the bigger number that is with that x term, the faster y is going to increase, or the steeper the line becomes. Finally, we're just going to see what happens when we have a negative gradient. Both of these ones have negative out the front of that x term. For the first one, it's negative x, which just means minus 1. And in front of that second one, it's minus 2. For both of these, the y-intercept is the same. We're going to be moving through that vertical line at 1. So we can see straight away how these gradients change if it's a negative number. So instead of going up in the last one, the line seems like it's sloping downwards. And what's happening is that every time x increases, or any time that x moves this way, the y value is going down. So that's what results in this downward sloping line. We can see straight away that it goes through the y-intercept of 1, so it's moved the whole line up 1, but it's still trending in that downwards direction. So when I add the line y is equal to negative 2x plus 1, it still goes through the y-intercept at the exact same point, but this time the y value is decreasing twice as quickly. So as x moves over 1, the y moves down 2. And that's why this looks steeper again. So the gradient, even though it's negative, still results in a change in steepness or slope. So the way to think about it is if the gradient is negative, it's trending downwards. So the line's going in the complete opposite direction. You should always be able to tell if a gradient is positive or negative just by looking at it and going, oh, that one's going up, must be positive. That one's going down, must be negative. So what it's resulting in is as x gets larger, y gets smaller, and this results in the line sloping the other way. I hope you found this lesson helpful, and I'll see you later.